Hello, AP Chemistry students. Today I will be teaching you or cramming you per se on organic chemistry and functional groups and memory tricks. So, yeah, as I said, I'll be teaching you about functional groups and I'll be including like neat memory tricks to help the information stick with you if it's hard to memorize through the notes or any other means. So before we discuss into functional groups, I just wanted to give you my memory trick on how to identify alkanes versus alkenes versus alkynes because it's pretty useful for me. So before I go into the memory trick, let me tell you the difference between each three. So alkanes are fully saturated hydrocarbons with single bonds. Um, they have the general formula CnH2n plus 2. Alkenes are unsaturated, which means they have at least one double bond, and they have the formula CnH2n. And then alkynes, however, are also unsaturated, but they have a triple bond, or at least triple bond, and the general formula is CnH2n minus 2. So my memory trick is kind of interesting. So it's more like an alphabetical thing. So as they alphabetically progress, they get more complex. So alkanes, since it's an A, it's the beginning of the alphabet. As you can see where the arrow is. It's the least complex. It has all single bonds. Alkenes, next, it has double bonds. Alkynes, the last in the alphabet, or from these three, it has triple bonds. So that's how you memorize how alkanes are the least complex, then alkenes, because they have a double bond, I call them quote unquote more complex. And then alkynes, since they have a triple bond, they're the similarly air quotes most complex. Okay, so now as we dive into the functional groups, I'll first talk about alcohols. So alcohols contain a hydroxyl group OH, and they're named with the suffix "-ol". So the helpful memory trick I use to remember that alcohols have a hydroxyl group or an OH group is by looking at its name, alcohol. So as you can see, which I underlined, bolded, and capitalized, whatever, you can see that there's OH in its name, which means that there's going to be a hydroxyl group. And then similarly to the way I remember that it has an OH group, to memorize the suffix of its name, I just look at the name itself, alcohol. At the suffix in "-ol" is "-ol", and that's the suffix to what you use to name alcohols. So in this practice problem or question or whatever, so the way we name it is first we identify that there's a hydroxyl group, so that it's going to be an alcohol. And once we've identified that it's an alcohol, we see that there's two carbons. So because there's two carbons, we know that it's going to be some alcohol form of ethane, and because it's an alcohol, it's going to be ethanol. So here you can see the hydroxyl group is circled, and then it's called ethanol. So aldehydes. So aldehydes and ketones are kind of similar, but they have a few notable and important differences. So aldehydes contain a carbonyl group at the end, and a carbonyl group is just C double bonded O, and they're named with the suffix "al". Ketones, on the other hand, contain a carbonyl group in the center, and by center I mean just not the outside, and they still have a carbonyl group which is the same, C double bond O. However, ketones are named with the suffix "-one". So the memory trick I have for aldehydes are aldehydes on the outside and ketones in the middle. So as you can see, aldehydes are the aldehyde is on the outside, and since we've identified the aldehyde, which I will circle, we know that since there's 1, 2, 3, 4 carbons, we know it's going to be some form of butane, and since it's an aldehyde and they have the suffix "al", it's going to be butanol. Not butanol, butanol. So ketones. So ketones, aside from the memory trick I use for aldehydes, which is aldehydes on the outside and ketones in the middle, I use ketones. They look like a keyhole, and they have a keyhole that has like carbon on each side, and like as you can see, the oxygen looks like the keyhole part. And anyways, okay. So in this problem, as you can see, since you see that you can identify the carbonyl group, you know that, and the carbonyl group is in the middle. You know that it's going to be a ketone. And since there's 3 carbons, you know it's going to be some ketone formation of like propane. So because it's a ketone and it's going to be, and there's 3 carbons, you can name it, once you've circled and identified the carbonyl group, you can name it propanone. Okay, so carboxylic acids. So carboxylic acids contain a carboxyl group at the end, or a COOH group, and they're named with the suffix oic. So my memory trick for carboxylic acids is that carboxylic acids are cool at the end. So like it's like carboxylic acids are cool at the end, but cool. So that just helps you remember that there's a COOH like group at the end, or a carboxyl group at the end, and the suffix you just have to memorize. You'll get it eventually. Oic, 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 oic. So then, for example, in this one, we can identify that it's a 4-carbon chain, so we know it's going to be some form of butane, and because it's carboxylic acid, it'll be butanoic acid. So in addition to the oic, you add acid. So circle the carboxyl group, and it's named butanoic acid. Okay. Esters. Okay. Esters are interesting. So esters contain a carboxyl group in the middle, not on the outside. So the COOH group is in the middle, and they're named with the suffix OH. So the memory trick that I use for Esther, which is quite interesting, is that there's this girl in our class named Esther, and I kind of made up memory tricks based off of her. So Esther was born in 2008, and then 2008 can also be deemed 08, and 08 is the ending or the suffix for an Esther. So Esther has 2 Korean siblings, which means she has 2 O's, because I imagine siblings as just like cute little like heads, whatever, and heads look like O's. And then Esther smells really good, which is why esters smell good. Okay, so esters are also, not only are they difficult to memorize, unless you have this memory trick, of course, they're difficult to name. So first you have to identify the carboxyl group in the middle of the hydrocarbon, and as you see, I circled the carboxyl group right here, and then you have to split the hydrocarbon into 2 main sections. So from the oxygen, so here's the split. It's always going to be in that area after the oxygen, and then so once you've split it, you name the right side first, which is the part branching off from the main group. So that's just methyl, and then since it's a 3-carbon chain, it's going to be some form of propane. But since it's an ester, it's going to be propanoate. So then when you combine them, it'll be methylpropanoate, as you can see right there. So amines. Amines contain an amine group, NH2. They're named with the suffix amine, and if there's no functional group, it's named with the, if there's already a functional group, it's named with the prefix amino. So a nifty way to remember amine has an NH2 group is by thinking it's spelled differently. I spell it like amine, which has like NH2 in the middle, amino, and a memory trick to remember the more commonly used prefix is that amines have the prefix in its name, amine. So in this example, you can see that it is a 1, 2, 3, 4 carbon chain, which you know it's going to be some form of butane. So whenever you add the suffix to it, because there's no functional group already, it'll be butamine. See, there, as circled is the amine group. Ethers. Okay. Ethers contain a lone oxygen with hydrocarbon chains on each side. Each hydrocarbon chain has a suffix ether. So, for example, my memory trick for this is that ethers have hydrocarbon chains on either side of the oxygen, like ether, ether. So the suffix is the name ether. So in this example, once you've identified the lone oxygen and hydrocarbon chains on each side, you can either call it 2-methyl because there's 2 methyls on each side, so methyl-methyl ether, or more simply dimethyl ether. So a quick cram. So in this quick cram, I'll quickly go over all of them. Alcohols, the memory trick was alcohols, like OH, it has a hydroxyl group. And then it's named with all at the end because alcohol. And then aldehydes, aldehydes have the carbonyl group at the end, aldehydes on the outside, ketones in the middle. So then it's named with the suffix al. Ketones, as I said, they have the carbonyl group in the middle. They're named with the suffix -one. And ketones look like a keyhole. Carboxylic acids, they have a carboxyl group at the end, or a COOH. Carboxylic acids are Cu at the end, and they're named with the suffix oic, 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 oic. So hopefully that sticks in your mind. Esters is a weird one. It has Esther was born in 2008, 08. She has 2 Korean siblings, which means that she has 2 O's because heads look like O's, and she smells good. That's just extra information. And esters have a carboxyl group in the middle, not on the outside, unlike carboxylic acids. Amines contain the amine group NH2. They're named with the suffix amine, and the way I memorize it is by spelling amino different with the NH2 in the middle, and the prefix, the suffix is amine, which is in the name. Ethers contain lone oxygen with hydrocarbon chains on ether side, and then it has a suffix ether, and yeah, that's pretty much it. I hope the lesson went well. I hope you are ready for your test, or the AP test, which is probably coming up soon. Yeah, good luck. Best of luck, study hard. Thanks.